whether there's anybody there.
There's a few people here, which is good. There's about 15 people. So welcome everybody to our 98th Reading Online Sport Economics Seminar. It's great to have Ruud Koning presenting. Ruud was one of the first presenters way back in March 2020 as we all sat under lockdown. He presented a paper on how we might finish competitions given disruptions from a pandemic like we've had. It's great to have Ruud back. We're obviously now meeting back in person as well as still meeting online, which is great. Just before Ruud starts, a reminder, and I'll put in the chat the link to register for the Mathsport International Conference if you're interested in attending. I'll put a link to the website. We've got a fantastic lineup of presentations in just a couple of weeks' time, less than a couple of weeks' time, the 11th to the 13th of July. Please do consider that. And hopefully you're also thinking about going to the European Sport Economics Economists Association annual conference in Helsinki in August as well. And the final thing I'll just say in terms of mark the dates is that we're planning to have our second Reading Football Economics Workshop in December, 13th and 14th, to coincide with the semi-finals of the World Cup in Qatar. The conference, unless someone happily sponsors us and takes us to Qatar, will be in Reading, unfortunately, rather than Qatar. But we hope to have a great follow-up to our first conference where we had close on 100 delegates in Reading and some great presentations. Without holding up Ruud any further, Ruud's talk is entitled Determinants of a Country's Paralympic Success. Ruud, please do take away your presentation.
Yeah, thanks a lot. Thanks for the invitation and the opportunity to present this. This is joint work with Jari Visser. And Jari Visser is a student here at the University of Groningen, and he just graduated. And now he's off to well-paying jobs, I guess. So this story is about well, it's about econometrics, and it's also about Olympic success. There's a big literature, sizable literature on a country's Olympic success. And there's very little on Paralympic success. So that is basically what got us started. There's a paper by Butts that is the only paper that we are aware of that look at the determinants of a country's Paralympic success. And they follow this paper by Bernard and Busse in the Review of Economics and Statistics 2004. They estimate the random effects Tobit model, and there's something well, that's following the literature, but on the other hand, we feel that there's a catch there. So in particular, in this paper, when we were talking about this, we said, yeah, I don't know if this country-specific effect, this random effect, is all that uncorrelated with the covariates. So that is the econometric part of the paper. If you can we allow for some correlation between random effects, the country-specific effects, and the covariates. So we find that that is possible, and also we find that this correlation is significant in this case. So the standard model, the random effects Tobit model, as used by Bernard and Busse, may give incorrect results. So we allow for this correlation between the unobserved country-specific heterogeneity and the covariates by taking the approach of Mundlach, and that is the correlated random effects Tobit model. And then we don't have a very big size of big number of covariates. We have GDP per capita, population size, political regime, and whether or not it's a host country. Those are kind of the standard ones. I will get back to that when I indicate some of the literature. Now this model is estimated using quite recent data, 96 to 2016, and it shows that in particular population size is weakly related to Paralympic success, and GDP per capita is strongly correlated. And we don't find this result that has been documented elsewhere in this type of literature, that communist countries or formerly communist countries are outperforming others. So that effect is no longer there. And do note that we have a somewhat more recent and shorter panel, so that may be related to that. Okay, so that is the talk. So basically, if you want to watch Formula One racing, if that's on TV at this moment, then the short summary is that Olympic success is more determined by population size, population size. Paralympic success, GDP per capita. So they're different covariates. So it's a different, equation or different model that you need to estimate. Moreover, the assumption of no correlation between the random effects and the covariates is not correct. And consequently, you have to estimate these models differently. Okay, so the reference model is this Bernard and Busse model. And we look in particular at what are the determinants of Paralympic success. And we start with this Bernard and Busse model, and then we slowly build it up from there. So we use different estimators, and consequently or not, we have some different findings. So So we close this gap in the literature on the determinants of this Paralympic success, because not so much has been estimated in that field as yet. And also it's interesting to compare our results with the results on Olympic success. So this issue of replication, I find important. Now, so there are a couple of relevant papers here. Bernard and Busse, that should be 2004, I think, not 2014. Butts, 2013, estimated the random effects Tobit model in both cases, and Reade, forgive me the pronunciation. He estimates a correlated random effects Tobit model, so in that sense he's closer to our approach. Now, so we find that our results are roughly in agreement with what the others have found before. So this is the main literature. There's a paper in 1974, Grimes, Kelly, Rubin in the Social Science Quarterly, that analyzes the medal distribution of the 1972 Olympics. So that's one Olympics only, so it's basically a cross-section. There's no panel component to it. Then there's this paper by Bernard and Busse, 2004, in the Review of Economics and Statistics. There's a paper by Butts, Dubois, Heindels, and Jegers in the Journal of Sports Economics. They are the only one doing Paralympic medal success. And Reade in the Journal of Sports Economics, which is quite recent. Now, what do these papers find? I've made this table. So in Grimes, it is 72 Olympics only. They take population into account, positive effect, GDP per capita, positive effect. Obviously, you cannot take the host country effect into account because you have only one Olympics, and positive effect for communist countries. So communist countries were doing better than based on the expectation based on population size and GDP per capita. Then Bernard and Busse have extended this model by also looking at Olympics. They've added host country. They've made a panel. They use panel data estimation. So the effect of a host country is identified. Butts is the only paper doing Paralympic medal success. And if anyone has seen another paper on Paralympic medal success, please let me know. That would be extremely helpful. And Reade is also looking at Olympic medal success, medal shares. And interestingly, Reade finds differently from Butts that population size matters positively. GDP per capita is not significant. Being a host country is significant, so you win more medals than expected based on the other covariates. And the effect of being a former or communist country is no longer relevant. So yeah. So these this issue of this communist countries, it's a bit difficult, of course. And for one thing, if you have a longer panel, your results may be tainted by the boycotts in the 1980s. And the Moscow Olympics, I think the Montreal Olympics were also boycotted by countries from Africa. Moscow Olympics were boycotted. Los Angeles Olympics were boycotted. So that's kind of a difficult covariate, and that's an advantage of our shorter panel, that we're not well bothered by these boycotts. A point that has been made by Vladimir Andreev, if I remember correctly. Host countries win more than expected. That is shown in this graph. So you see the medal share of each host, and then the square is the observation where that particular country organized the Olympics, and the other points are the other years. Well, you see that in the run-up to the organization of Olympics, there's already investment in sport facilities usually. So you see that in the run-up, they increase the medal shares, and the maximum is usually, it's quite high when you're hosting the Olympics. And that phenomena is apparent both in Olympic Summer Games and Paralympic Summer Games. So that is the host country effect. Except in Greece, they were a bit too late with the effect for the Paralympic Games, I guess. So the data, we got our data from the period 96 to 2016. Summer Paralympics and Olympics only, not the winter ones, because the winter ones is the choice is a bit difficult, and the capital investment also. So I think maybe you need another model for that. By choosing this particular time period, there are no boycotts, and basically you don't have to deal with the dissolution of the former Soviet Union. And it stops in 2016, so the current global situation doesn't have to be taken into account either. Variables that we have is the medal share. So that is from the official websites of the Olympic Games and the Paralympic Games. And you can use other measures of success. And there is this medal point share, 3 points to a gold medal, 2 for a silver medal, 1 for a bronze medal. Well, that's highly correlated with just a plain simple medal share. So we don't distinguish between gold, silver, and bronze. We didn't want to look at the actual ranking, because the ranking may change because some country that is better than you in the first place gets more dominant. So we think that is a disadvantage of that ranking. It is important also to allow for some relative measure, because the number of medals, the number of events has increased over time. So for that reason, I've included time-specific dummies in all specifications, even though these results, these point estimates are not in the tables. We have population, GDP per capita, that is from the World Bank, averaged over the last 4 years before any particular Olympic. And there's the Polity 5 measure. That is a measure that's slightly, well, more refined than this communist country or no communist country. So it's -10 to -6 for autocratic regimes, -5 to +5 to anocratic regimes, and 6 to 10 for democracies. So the UK in 2018 was an 8. I think in, say, 2010 or so, it was 10. So UK has become slightly less democratic over time, according to this measure. And if you look at Turkey, there's a big change. Last value is -4. And in 2000, it was value 7. Well, if autocratic countries are more successful for one reason or another, we should find a negative coefficient for this particular variable. So this is the advantage of using this variable over the dummy. The communist country dummy is that this one can change over time, and it's a bit more, well, granular if you want. This is the medal share distribution of the 1996 Paralympic Games. And there are 44 countries that do not have any medals at all. And in total, there are 104 participants. So the fraction of 0 medals is non-negligible, and as a consequence, we have to take that into account, that truncation at 0 in our modeling, approach. So this is data, and for the other years it looks very similar, the distribution. So there's a noticeable fraction of countries that does not win any medals at all. An example of the correlation matrix. So we have medal share, that is our dependent variable. The 3 independent variables are shown. And well, you see that the correlations are quite pleasant, in the sense that by looking at GDP per capita, we've kind of avoided the problem that population size and GDP tend to be highly correlated. So that's a bit of an artificial trick to reduce that correlation. And yeah, with this correlation, we get to work. So first estimated model is a pooled Tobit model. And that is also the starting point of the Bernard and Busse approach. So the latent medal share, MIT star, is intercept plus population size, GDP per capita, this Polity 5 variable, and the dummy variable indicating whether or not it is hosting the Olympics. And then the Z's are the time dummies. And then if this latent construct is positive, we're assuming that we observe the outcome, and otherwise, if it is negative, we observe 0. That's kind of a standard Tobit model. C, I refers to the country, T refers to the time period, the time of the Paralympics and Olympics. So there are no country-specific effects. All variation between countries is supposedly captured by these 4 variables and the time effects. Now that is maybe a bit inconvenient notation. So I have the XIT vector, which is bold. So I write it like this. And then you see that the X vector contains the variables of interest, the Z vector contains the time dummies, and the key assumption is that distribution of the error term epsilon it conditionally on the observed covariates and time effects is normal with mean 0 and variance sigma squared, and it's IID, independently identically distributed. Now, so that is the pooled Tobit model. So that is the first model we're going to estimate. I go through the models first, and then I will show you the estimation results. Well, then in the second step, Bernard and Busse, they extend this model by adding country-specific effects mu I. So now there is for every country a time-invariant country-specific effect. And there are two key assumptions. The distribution of the epsilons conditionally on the country-specific effects, the observed covariates and the time effects is normal. And the distribution of the country-specific effects given the covariates and the time effects is normal with mean 0 and standard and variance sigma square mu. So this second assumption, the distribution of the country-specific effects conditionally on the observed covariates, imposes no correlation between the country-specific random effect and the covariates. So this is the random effects Tobit model, and this is the celebrated specification that is used in the paper by Butts and others, and Bernard and Busse. Now, what is the implication of this assumption? Well, one of the xi variables is GDP per capita, and yeah, you could argue that countries that are inclusive to Paralympic athletes, they probably have a higher value for mu I, but they because of this inclusivity, they may also have a higher value for GDP per capita. So if that is the case, and in particular in the case of Paralympic success, that is a reasonable assumption to maintain, and also substantiated by a paper by Banks, 2014. So if you believe in that assumption, there's every reason to relax this assumption, the assumption of no correlation between country-specific effect and the covariates. So we would like to allow for correlation between the country-specific random effect and the covariates. So how to go about that? Well, there are two options. The first option is the correlated random effects Tobit model, and that is based on the Mundlach transform. So Mundlach says, okay, you should model the country-specific effect as linear in the mean plus a random error term. And that is written here below. Mu I is xi bar, that is the time invariant mean of country I for all the covariates, plus wi, and wi is then normally distributed. So this Mundlach transform, this correlated random effects Tobit model, requires a balanced panel. So later, I've done some tests following a suggestion by Wooldridge, and it turns out that that balanced panel restriction is not consequential for the point estimates. The interesting feature of this particular specification of the random effects is that you can test for the relevance of random effects by testing whether this vector psi is 0 or not. So that is the correlated random effects Tobit model. And then there's even one more complicated model or estimator available, and that is the one by Honoré. So we go back to country-specific effect mu I, and we allow the unobserved heterogeneity to be correlated with the covariates. And that is what, if you believe this inclusivity to people with disabilities, if you believe that story, then this is what you want. You want to allow for correlation between covariates and the country-specific effect. So Honoré says, okay, what we can do is we make the assumption not about the mean of the distribution of the epsilons, but about the median. So we make the identifying assumption that the median is of the epsilons conditionally on the country-specific effects and the covariates. That should be 0. Then if we assume exchangeability of the error terms, then the error term of country I in period T and the error term of country I in period S, this joint distribution is the same as if you look at the error term in period S and error term in period T. If these two are identically distributed, conditionally on all the observed covariates and the country-specific effects, then you can estimate the slope coefficients beta and gamma. Now, this looks attractive, but there's one disadvantage, or at least one disadvantage. You don't get any point estimates for the country-specific effect itself. This exchangeability assumption, it's kind of a symmetry assumption. The symmetry assumption allows you to take kind of differences, which gets rid of these country-specific effect, but as a consequence, you cannot estimate it. There's no way to estimate it, so there are no average population effects estimable. So it is a semi-parametric estimator, very flexible, but it comes at a price. It comes at the price of this assumption of exchangeability. It comes at the price of no average partial effects, and it comes at the price of larger standard errors that I will show to you in a few minutes. So these are the results of the random effects Tobit model. I've included all the well-known and the variables that I've discussed. The log population size, log GDP per capita, all has the expected signs. Notice that this polity phi variable is nowhere significant in this specification. The population size, GDP per capita, have the signs as expected and are highly significant. And also you see that the order of magnitude of log population size and log GDP per capita are kind of similar, both for Paralympics and Olympics. So as a consequence, from this specification, you would get the impression that only GDP matters, absolute GDP. Dollars only. Well, that is the story of the Tobit model. So even though it says random effects Tobit model, it is not a random effects Tobit model. This is the pooled Tobit model we started with. So what then about the random effects model? That is the one that Bernard and Busse introduced. Well, you see that estimation results are a bit different. For one thing, notice that the point estimates are quite different, and the effect, the average partial effect of GDP per capita in the equation for the Paralympics is quite different from the average partial effect for the Olympic medal share. So from this, you would get the impression that GDP per capita has different effects, and it has a stronger effect for Paralympics than for Olympics. Again, this polity phi variable is not significant. So in our shorter panel, this doesn't matter so much, and being a host helps a lot in improving your medal share. So this is then the random effects Tobit model. But now let's look at the correlated random effects Tobit model. So the one that allows in a simple way for correlation between the country-specific effects that are also behind this table and the covariates. Well, interestingly, we find that population size is no longer relevant in the medal success for Paralympic Games. Population size is relevant, is statistically significant in the equation for the medal share for the Olympic Games. GDP per capita is relevant for Paralympic success and no longer statistically relevant for Olympic success. And again, the being a host matters and helps all the time. So how would that be possible? Well, many athletes, also athletes from, in particular athletes from poorer countries, are able to train and get access to facilities, medical care in richer countries. So the idea that GDP per capita is relevant is perhaps, yeah, by now in recent dates with travel abound, not so relevant for these elite athletes. And the top runners all train. Many of them train in the United States, sprinters. And it doesn't matter so much if you're coming from Jamaica or the United States. What matters is that you are a fast sprinter. So from that point of view, you could argue that GDP per capita is probably not so relevant no more for Olympic athletes. However, Paralympic athletes are much more dependent on the funding of their local government than Olympic athletes. This global market for talent training facilities is much less developed for Paralympic athletes. So in that case, the GDP per capita, the amount of resources a country can spend to support Paralympic athletes is relevant. So yeah, if you think about it that way, this may not be surprising, but it shows that in this correlated random effects Tobit model, that there are different covariates relevant for Olympic success in the medal shares compared to Paralympic success in these medal shares. And again, being a host country still matters. Well, finally, we've estimated this model of Honoré. If the specific correlation structure that is allowed in this Mundlach transform, if that specific correlation structure is restrictive, then maybe the approach by Honoré would give wildly different results. Now, maybe remember that standard error of log GDP per capita in the Paralympic equation is 0.0022. And you see that it is here much larger, 5 times as large. So in general, the standard errors are higher, so there are fewer stars indicating significance, but still log GDP per capita is significant in the equation for Paralympic success. Population size, so the talent pool in sheer numbers, is relevant for Olympic success. So basically, the message of the correlated random effects Tobit model is confirmed using this estimator, this semi-parametric estimator by Honoré. And also in Honoré's model, we find that the being a host helps. So conclusions, well, GDP per capita, it explains Paralympic success. Population size explains Olympic success, once you allow for correlated random country effects. The statistical test that we use to test for this xi is equal to 0 showed that you have to allow for correlated random country effects. So being a host is everywhere significant. Political regime is not significant. And well, the determinants of medal share differ significantly between Paralympic and Olympic success. So that was also tested formally, and that was the conclusion of that test. So Paralympics are different. If you want to benchmark your Paralympic success of a particular country, you cannot use the equation for Olympic success in the medal shares. You have to create a separate benchmark. And at this moment, Paralympic success is indeed mostly determined by GDP per capita. So basically a measure of the resources that a country can give to the Paralympic athletes. So that's the story we have. Paralympics and Olympics are different, and not only from for the athletes themselves, but also for covariates relating the medal share to observables.
Thank you very much, Ruud. Very interesting talk on the determinants of Paralympic success. Questions and comments? Jean-Louis. Can't hear you, so I don't know if you're on mute.
Can you hear me now?
Yep, got you now.
So thank you for this very challenging and interesting presentation. It seems that there are at the end on the estimation of parameters different results. I would like to know on the overall, did you compare the models on the basis of such criteria as AIC, BIC, or things like that to compare the relative efficiency of these different models on the overall?
No, I haven't done that yet. That is
but
something.
It might be interesting,
Yeah.
no? Because
Yeah.
maybe there is not so much difference at the end, because there could be compensation between the different part of the model, no?
Yeah. No, you're very right about that. But at this moment, Jari and I haven't done that yet. But definitely we're going to do that. Thanks for that remark.
Yeah. And maybe also to look at some diagnostic tools, such as the distribution of residuals on the samples. No?
Yeah.
Yeah.
Yeah. And
So
then,
some softwares do that very well. No.
Yeah. In particular, this estimated by Honoré.
Yeah.
That it doesn't like it doesn't mind correlation over time. Doesn't mind that too much, but it doesn't like heteroscedasticity that varies over time, and that's something we should look at. Indeed, yeah.
And did you look at the simple model without any random effect, just the basic model with covariates? I think the model 0.
Yes. But that was the one that had the incorrect title on the transparency.
Yeah.
It said the random effects Tobit model, but it should be pooled Tobit model. So that we've estimated, and then you get this result that is a bit misleading, I think.
Thank you.
Thanks, Jean-Louis. More questions and comments? Stefan.
Hi, Ruud. So there's sort of an interesting literature this about Olympic medals, and I was wondering what you thought, whether you tried. So Roger Pielka has this critique that says that actually the most of these models are beaten by in prediction by a simple model where you say current metals equals lag metals. Did you look at that?
Well, so basically our departing point was not so much an optimal prediction model, but it was very about the correlation between the random effects and the GDP per capita. We had a long discussion, Jari and me, that countries that are well inclusive could get more medals and also would be probably have a higher GDP per capita if they don't waste resources like that. So that was the starting point, more from a methodological point of view, and not from an optimal prediction point of view. I think from an optimal prediction point of view, there's a lot of autocorrelation, and you see that also in the to some degree in the graphs that show the host country effect. It is quite flat, all these graphs. So if you were to put a gun at my head and say, well, what is the or something else? What is the medal share of the United States in the next Paralympics? Then I would say, well, the one they had in the Tokyo Paralympics.
So I mean, is there any special advantage to looking at this issue of the random effects in this particular context? I mean, I would have thought. I mean, it seems like it's an econometric point. It's a matter of statistical theory, and you'd almost might be better off looking at, say, something like international football match results, because that would give you. You'd have a richer data set, and you wouldn't be reliant, because I think always this problem is that, you know, you've got this very strange situation where you've got all the medals concentrated in the hands of a very small number of countries and a very large number of countries that are getting nothing. And I know that fits the obviously that's a Tobit, but even so, it's just a very strange setup in general.
Yeah, but well, I think that we looked at well, Denmark and Finland are not too different. These two countries, also quite similar GDP per capita, reasonably similar political institutions, reasonably similar population size, and still Denmark wins many more, has a much higher medal tally than Finland. So. I think that there is reason to use these country fixed effects, and then if you do that, then do it properly. So it's always easy to be critical of the work of others, but I think well, the two important messages here are first of all the covariates differ. Paralympics is different from Olympics. Well, that may not be so shocking. And then secondly, you should use a correlated random effects estimator and not one that imposes no correlation, because in the end it matters to the results, right? So it matters on what you believe is in the data.
Yeah, I mean, but so I guess the other question is, you know, couldn't one say a lot more about policies towards differently abled people in different countries? I mean, that lies at the heart of what's going on with the Paralympics, and that's something which we have presumably quite a lot of observables for. So in some sense, you know, we do know why Denmark does particularly well at this, is that Denmark has particularly progressive policies in this area. Isn't that the explanation?
That could be, but I don't have. Unfortunately, we've looked into finding data on this inclusiveness to disabled people, and we've not been successful in finding a data set that is consistently measuring the same thing over large set of countries and so on. So I would like to believe you, but that would be a leap of faith and not backed up by data at this moment. So for the moment, this is all hidden in this country-specific effects still.
Right, but I have to say I don't believe that population doesn't matter. That seems like a leap of faith, which you know, the day I'm not. So it's an interesting question. You know, on a priori, a larger population must give you a better chance to have more athletes. So there's something about, there's policy variables that are interacting here that are somehow limiting the effect of the population. And why? Because one of the things is that, I mean, in some ways, it's not so much the differences between the countries that get the medals that's interesting. It's the differences between all of the countries that never get medals. And I would so there's a very big difference between, I don't know, St. Kitts and Nevis not getting any Paralympic medals, and I don't know, think of some large I don't know if Kazakhstan gets medals or Uzbekistan gets medals. I suspect not many, but I mean, all those zeros are actually very, very different amongst each other, and I don't know how you can capture that without some more policy variables thrown in.
No, I agree that the dynamics will be it will be very interesting to have a thorough understanding what makes a country go from the 44 that has a 0 medal tally to getting some. Is that policy, or see, another reason could be that there's been an armed conflict, that able-bodied former servicemen pursue an Olympic, Paralympic career. So maybe that is one that we could try to add.
Yeah, I mean, there must be global data on military spending per capita, right? That seems to be, and particularly lagged military spending per capita might well have. I mean, you think that again, that does lie at the heart of how it emerged from the UK, right? It was soldiers from the Second World War, right? And you think Britain has been, you know, Britain's interest in this has had a lot to do with the disabled people coming out of the army, right?
Mm. Yeah. Good. Let's look into that.
I can say that kind of data certainly exists, Reade. I have a PhD student who's been working on looking at military spending and also development, and trying to also factor in military conflicts. So that's internal and external. So I can certainly get to you a reasonably thorough data set of countries around the world via my PhD student. I'll get her to get in touch with you. Something else that was come to mind based on Stefan's questions was whether you've looked at the World Values Survey, because that has a lot of questions. I don't know whether anyone will be particularly getting at the whole idea of progressive policies, popularity, and so on. And of course, it's a survey of people rather than any kind of index of what governments are doing. But that's another possible source of that kind of data. And
is that done repeatedly? I don't know this this one, James, but
there are waves of they seem to be about every 7 years or so. So I mean, I think over your time period, you'd probably pick up 2 or 3 different waves, I think.
Yeah, because you need it, otherwise it disappears in the country specific effect.
Yeah.
Another thought that comes to mind is maybe you could maybe it would be useful to use the data on the number of athletes competing from each country. So, I mean, one of the things it might be is that I can imagine that GDP might matter more in terms of winning medals than it does in terms of sending athletes. And so, I mean, that difference, whereas I don't know, population size might matter more for the number of athletes that you send.
Yeah, in fact, I didn't show that, but we have a graph that shows the the number of athletes competing, and the host country effect is due to more athletes from the host country participating. So that is definitely there.
Well, and presumably that. I mean, it's interesting contrast with the Olympics, where, I mean, that because the host country automatically gets entrance, right? That's the hope. That's the whole point. You don't have to qualify. But that's not that in the Olympics. That doesn't necessarily help you very much, because you're still competing against. There's a lot of athletes, and so it's not really going to help you with medals. Whereas because there's fewer athletes, there's a smaller pool of athletes in the Paralympics, and it's a smaller activity. Actually, that host effect probably does make quite a big difference in your potential to win medals.
Yeah, well, you saw that the point estimate of a host effect was large.
Right, but that's for medals, right? But I would say it'd be smaller for medals. It would be smaller for the Olympics itself, right?
It is smaller for the Olympics, yeah. The host effect is smaller for the Olympics, yes, indeed. If you believe the story of Stephen Jay Gould, that it takes time to build up concentration to the top, and you could argue that Paralympic competition is relatively new compared to Olympic competition. And it was only in the mid 50s, 60s that the first Paralympics were organized, and maybe we are still in a time period where people are still not competing at knife's edge with each other.
Right. I mean, it's just a smaller pool, right? It's a much smaller pool and a much less diverse pool than for the Olympics, right? I mean, I think that's so. Using the data on the number of athletes entering from each country would, and also, the Olympics has qualifying times, right? So minimum qualifying times. I don't know how the Paralympics works in that respect. Do you have minimum qualification standards as well?
Yeah, Jari would be able to tell you this, but he's not here.
But I mean, exploiting those differences might help you understand better what's causing the variation in medals as well.
Definitely.
I actually thought the question Stefan would ask you was about GDP and whether it should be in there as a relative share of GDP across all countries, because you've got GDP just in per capita, right? And you're explaining number of medals in a competitive field. I don't know if you've tried looking at GDP relative to all the other countries that are competing.
I didn't do that, but I will run that, I promise you.
Any more questions and comments?
Although GDP, I've taken it in log form, and then if you take relative GDP, it is constant, and it will disappear in the time dummy, I think, in the time effect that I did. So I have to think about it, whether it makes sense or not. Maybe I've done it by having time fixed time effects.
I mean, it might also be that there are discontinuities in the GDP per capita effect as well. So, I mean, it might be you need to cross a certain threshold before governments have policies which are aimed towards enabling differently able people to participate in society more generally, and that's critical. So maybe it's not maybe there's a threshold there that you should see if there are any thresholds that stick out in the data. I mean, presumably the medal winners are presumably mostly rich Western European nations, right? I mean, that's the bottom line, isn't it?
Yeah, the answer is yes. Yeah. So and then in the end, well, in that graph that I showed, there were 104 countries participating. So that is less than at the regular Summer Olympics. There is a whole bunch of countries. So there are three phases. There are countries that are not even participating. And this study doesn't learn anything about them. Then there are countries who have 0 medals, and then there are countries with a positive medal share. So we are looking at that second, from step 2 to step 3, not from step 0 to step 1. And then you would imagine that if like food is a macroeconomic concern in a particular country, then maybe some of these sports are of lesser importance.
Well, presumably you could look at that. You could do that as a 2-stage process, though. The model, the participation decision, as well as the medals.
Yeah.
So the participation decision is the number of athletes you send, right? And so there's so you've got a Tobit there with a lot of zeros, and then conditional on that, you've got the number of medals, which is another Tobit, right? You could nest those two together, couldn't you?
Well, definitely you could estimate both. You would expect if there are, in fact, I would expect if there are any discontinuities, thresholds as far as GDP per capita is concerned, that would be more from whether or not to participate than in that second stage, because these 104 are probably somewhat better off already. Well, what is it? 90 countries that are not participating at all. That there will be a bigger difference in GDP per capita. That would be my guess, but
yeah, but there's also politics though as well, right? I mean, I think it's not just money, is it? I mean, different countries have different attitudes towards this, and I think it's probably important to try to model both of those aspects in the decision-making framework.
Yeah, we'll do that.
Any more questions and comments? Looks like it's a no, so in which case we can begin to wrap up. So thank you very much, Ruud, for a very interesting talk on the Paralympic Games. Slight tweak from the common focus on the Olympic Games, and some very different aspects to think about. Thank you very much for a really thought-provoking talk. We will return next week, and we will have Michelle Bartafi, who's from here at the University of Reading, one of our own, presenting COVID-19, gender and social pressure. So do join us next week, and in the meantime, wish you all a fantastic weekend.
Thank you.
Thanks, Reade. Thanks, everyone.
Thanks,
Thank you, bye.